Hi, this is the final video in the playlist where we've been looking at the sample assessment materials for Edexcel higher paper, and this is paper 3, the calculator paper. What I've been trying to encourage you to do is to keep stopping the video, having a look at the questions, trying them for yourself, and then comparing your solutions. This is the final few questions. They are the more complex, so hopefully they'll be okay for you, but if you do need any help, please don't hesitate to leave a comment. I'll always come back to you. Okay, so we're going to have a look at question number 16. Please do print this out and have a go for yourself. It will take a little bit of working through, but basically we're going to be using trigonometry. We're going to be using SOHCAHTOA and also Pythagoras in order to calculate this particular question. Really what we're looking at is that if we imagine one of these triangles here, now the difficulty we've got is that we've got an angle which is 55 degrees in the sloping edge. So what that means is, if you can imagine, if I draw a little sort of triangle in here, I can draw this so that I've got a right angle, and then this is actually 55 degrees in here. Okay, so it's 55 degrees of the triangle sloping away from you. Now, in order to achieve finding out this total surface area of one side of the triangle, what I have to do is I have to work out the vertical height. And this is where it's getting quite tricky for me, because I've got a lot of information to work with, and also I've got to use a couple of different ways of manipulating the information in order to get to that vertical height of one of the side faces. Okay, so I'm going to do my best in terms of the video. Hopefully it'll work out all right for you. However, I'm also going to make a note that because I'm working out the total surface area of the pyramid, I need to also just make a note up here that the base surface area is going to be 20 times 20, which is going to be 400 centimeters squared. So whatever my calculations are, I need to add that to the total surface areas of the triangles to get my overall surface area. Okay, so let's have a look at this. What I'm going to do is I'm going to make that point there M. Okay, now if I want to find the value of AM, so I've got to find AM first, then basically if you can imagine that is halfway between A and C. So what I've got is a right angle triangle, which is the base of the triangle. So it's this triangle here. So this extends along here and it sits flat on the floor. So AC squared equals AB squared plus BC squared. Okay, now if I work that out, I can say that's 20 squared plus 20 squared. That equals then 800. So the value of AC, which is from this corner to this corner over here, is going to be the square root of 800, which equals 20 root 2. Okay, right, well that's overall AC. However, I don't want that. I want to stop it in the midway point, which is AM. So I can write in here, therefore, AM equals half of 20 root 2, which is 10 root 2. Okay, so I've got one little bit of information, which is this length along here. However, because I've got that bit of information, it allows me then to work out the vertical height VM over here. Okay, now the reason I can do that is because essentially now I've got, I need to find VM. Okay, in order for me to do that, I can actually just use SOHCAHTOA. Okay, so I've got a point here, which is point A. I've got M and I've got V. Okay, now I know this is 55 degrees, and I've just worked out the value of AM as 10 root 2. Okay, so to find VM, I can actually use SOHCAHTOA TOA, okay, and what I'm going to use is the tangent relationship, because actually I need to find the opposite, but I do know the adjacent. So what I can do is I can write the tangent of 55 degrees equals the opposite over the adjacent. Okay, well, the opposite is what I'm looking for, but the adjacent is going to be this 10 root 2. So I can say that the opposite is equal to 10 root 2 times the tan of 55 degrees, and that equals the opposite. And if I put that into my calculator now, I'm going to get quite a long number, but it's going to be 20.1970628, and that equals the opposite. Okay, so what I've got now is this value of Vm. Okay, this is going to be Vm. Okay, and that's important for me because then I can use this to create yet another triangle. Okay, now this is where it does get a little bit tricky, because I mentioned before that what I need to do is I've got this kind of sloping triangle here, and I need to be able to find out this vertical height. Now I'm going to draw this slightly strangely, but if you can imagine, this here is the bit I'm interested in. I'm going to call that V at the top and let's say X at the bottom there. Now that's made up of another Pythagoras triangle, or right angle triangle rather, where the M is the midpoint, which I've just worked out, this VM height, so that's VM here, and then XM is the midpoint between the bottom sides of the pyramid. Okay, so this point here, VM, is going to be actually 10. Okay, because it's 20 overall, so the midpoint there is going to be 10. So it puts me in a position then where I can actually just use Pythagoras to say that Vx squared, which is what I'm interested in, is this slope height here, is equal to Vm squared plus Xm squared. Okay, and Vm I've already worked out, and it's all this little lot up here, so I'm going to write that out just for the sake of completeness. Okay, and Xm squared is far easier to write out, which is 10 squared. Okay, if I plug that all into my calculator, I'm going to get Vx squared equals 507.921345.8, okay, which means that Vx, which is the information I'm interested in, is going to be the square root of that, which is 22.5371104, and that's the information I'm interested in, because I can then use that information to work out the area of the triangle. So what I've got is now I'm in a position where I can work out this area by saying the area of the triangle is equal to a half base times height. Okay, I'm sure my writing isn't so good there, but base is going to be 20, which we know already, and the height is the length that we've just worked out, which is Vx. Okay, so I'm going to get a half, base is 20, multiplied by the height, 22.53 ... Okay, and once I put that into my calculator, I'm going to get finally an area of the triangle of 225.371104. Okay, and then it's really a matter of saying, well, actually I've got 4 of them plus the area of the base that we worked out before. So finally I can now work out the total area, and that's going to be 4, and if you want I'll put in here times 225.37 ... Okay, plus the 400. Okay, and when I put that into my calculator, I get 1301.484. So in order to answer the question, and again, please be very careful about reading the text, it does say correct to 2 significant figures. So correct to 2SF is going to be 1300. And if I just put a note in here, that's 2 significant figures. Okay, I hope that's all right for you. There's quite a lot of work with these types of questions towards the end. We've got question 16, which is this one, which is a little bit more sophisticated. Question 17 isn't so bad. And then question 18 is, well, takes a little bit of time as well. Okay, so let's move on then to question 17. And this particular one deals with, well, we're looking at exponential growth. Now, exponential growth is something, again, that's fairly new to the new specification. However, it is based very much on, effectively, it's compound interest. That's really what it's all about. So we can use the same idea. What we can say is at the start of day 1, there are 1,000 bacteria in flask A, and then we're told that it grows exponentially at the rate of 50% per day. So what that means is that on day 1, we've got 1,000 bacteria. On day 2, well, we're going to have 1,000, which is the original amount, but because it grows at a rate of 50% per day, it's going to grow by 150%. So that's multiplied by 1.5 as a decimal. So we're going to start here with 1,000, okay? That's going to now become 1,500. Let's have a look at day 3. Okay, well, day 3, we've got 1,000 original amount, and then it's 1.5 squared because it's been 2 days after the original one. So this is, if you like, this is the power of 1, now the power of 2, and that's going to be 2,250. Day 4 is going to be 1,000 times 1.5 to the power of 3, and that's going to be 3,375. And actually, if you work through all of this, what you'll be able to see is that you have got a geometric progression because each one is multiplied by 3 over 2. So that's times 3 over 2 times 3 over 2 times 3 over 2. And if you work out day 5 and day 6, you'll be able to see that happening for yourself. Okay, so therefore it is a geometric progression. Okay, and it's the common ratio is 3 over 2 or 1.5. Okay. Hopefully that's all right for you. It does take, again, a little bit of working through. There are some examples on the channel, so please do have a look at those. Okay, and then we're looking at, well, it's just really just a little bit of a development of that whole idea. It says the population of bacteria in flasks at the start of the 10th day is K times the population at the start of the 6th day. So let's have a look at the value of the population in the 6th day. Well, again, I'm going to do exactly the same, 1.5 to the power of 5. And if I plug that into my calculator, I get 7593.75. Okay, and then we look at the 10th day. Okay, well, the 10th day is going to be that to the power of 9, and that's going to be 38443.35938. Lots of big numbers in calculator type questions. Okay, now if you divide one by the other, what you'll find is that actually the value of K is going to be 5.0625. Okay, now in the mark scheme, it gives you the option of either this decimal or also the fraction itself. I can't quite remember what the fraction is, but the value of K, in other words, the amount of times it's grown, is just really what have I multiplied that by to get to that number? Well, I've multiplied it by that. So K in this particular case is 5.0625. Okay, and then finally part C, it asks you to draw a sketch of what's actually happening. Well, I think it's sometimes quite useful to actually not just draw the sketch, but also just drop in a few numbers. And you can do this exactly the same way that with Flask A, I've got a growth of 50%. Okay, yeah, Flask A, I've got a growth of 50% with Flask B. So in other words, the growth there is 1.5 and the growth here is 1.3 because it's 30% per day. And if you wanted to plot that out, you would end up with doing something like this. It's going to be a little bit difficult to do on a video, but basically you've got first day, second day, third day, fourth day, fifth day, sixth day. Okay, so this is basically time as it goes along there. Okay, and then we've got population. Okay, now they both start off at 1,000. So on the first day they've got 1,000 bacteria. Okay, on the second day, well, we've already worked out for Flask A. On the second day, we've actually got, if that's 2,000 there, we've actually got 1,500 for Flask A, okay, and then if that's 3,000 here, on the third day we've got 2,250. So what we'll find with Flask A is that it'll grow somewhere in the region like this. Okay, so it's going to go along here, and you can see now that the exponential growth is starting to improve. Okay, and by the time you get up to day 6, let's say, well, as we worked out there, we've got 7,500. So day 6, it's up here somewhere. It's off the scale a little bit. Okay, so we can draw that for Flask A. Okay, so for Flask A, it's going to grow at a slower rate because it's only a 30%. Well, so it's only a 30%. It is a 30% growth. So actually, for Flask, a big pardon, for Flask B, it's going to look something like that. Okay, and you could kind of plot that through. It's only 1 mark with this type of question, so don't spend too much time doing it. What they need you to demonstrate is you understand that Flask A is going to be a higher rate of growth than Flask B. Okay, so let's move on finally then to question number 18, which deals with vectors. Okay, now this particular question is just a little bit tricky. It's not too bad really, and if you've had some experience with vectors, then it shouldn't be so difficult for you. The interesting thing is that it says there where k is a scalar, qualities basically means a multiple. So what we're saying is that it's a multiple of mn and c. So MNC is a multiple of MN, and that's the important thing with this. Okay, so let's just have a look, and what we need to do first is work out the value of the vector of MC. Okay, so what I'm going to say is I've got MC. Well, in order to work out MC, so this is this vector along here, what I need to do is I need to work out the vector MA, so M to A, and then I need to go from there to there. So that's going to be equal to vector MA plus vector AC. Okay, so let's have a look at the first one. So MA, well, MA is going to be 3A. The reason it's going to be 3A is because we're told in the text that O to A is going to be 6A. Okay, so if O to A is 6A, then M to A, which is the midpoint, is going to be 3A. Okay, so we're absolutely fine with the vector MA. Okay, it's 3A. However, the difficulty we've got is the vector AC. So let's just have a look at that for the moment. So AC, we know, is twice AB. So the first thing we have to do is we have to work out the vector AB. So I'm just going to do this to one side. So vector AB, okay, is going to be, well, I don't know anything about this line along here, but what I do know is I can go along here and then down here. Okay, so vector AB is going to be equal to vector AO plus vector OB. Okay, so let's have a look at those. Well, vector AO is in the opposite direction to the vector that we're told before, which we're told is in this direction. So because it's in the opposite direction, it's going to be equal to minus 6a. Okay, OB is fine because we're told that OB is 6b, so that's absolutely fine. We can say that's plus 6b, so that's going to be minus 6a plus 6b. Well, I'm going to write that the other way around just to make it a little bit tidier, and then if I want to, I can say, well, that's 6b minus a. Okay, so what I've done is I've worked out this vector AB along here. Well, remember we needed to work out vector AC, which we know this is halfway. So actually, vector AC is going to be double this vector. So this vector AC is going to be plus 12 B minus A. Okay, so it's important that you make sure you've got the information that you require in order to complete this bit of information here. Okay, so then let's just work this out, and I'm going to have 3A, and if I expand this out, I've got plus 12B minus 12a. So 12b, 12 times b is that, and then 12 times minus a is minus 12a. Okay, so if I just then gather up my like terms, I'm going to get minus 9a plus 12b. Well, let's just sort that out a little bit as 12b minus 9a. Okay, I hope you can see that okay. And then I'm going to factor that for the value of 3. So that's going to work out as 3 4b minus 3a. Okay, hope that's all right and you followed that okay with this one. Okay, and this is really where your knowledge of vectors is going to be coming into the fore a little bit, because what we've been asked to do is, it says given that MBC is a straight line, find the value of k. Okay, well, what we're saying is that vector NNC rather, is equal to a straight line. Okay, so if it's a straight line, what we mean is that vector MC, if I put therefore, vector MC is a multiple of vector MN. Okay. All right, so if it's a multiple of vector Mn, then what we're saying is that MC, vector MC, is equal to 3 times 4b minus 3a, okay? So what we're saying then is that vector Mn, okay, which is this part of it. If I go back to the diagram, it's this part of it here. So we're talking about this line, MNC along here. So vector Mn is a multiple. So therefore, we're saying that it must be that if it's KB, okay, then it must be this value of 4 over here, okay? So vector Mn, if it's a multiple, then it'll be KB minus 3a, so this value of k equals 4, okay? All right, so a little bit tricky towards the end there, but it's this whole relationship where, because it's a straight line, vector MC is a multiple of vector Mn. Okay, well, we know that MC is 3 times that, so therefore this must be vector Mn, and therefore the value of k must be 4. Okay, I hope that's all right for you. It does take a little bit of time to work around. It is a trickier vector question than you would normally get, but if you have a look on the playlist, it'll give you some baseline vector type questions for you to have a go at on the channel as well. Please do add a comment below. I'm always happy to come back to you. Subscribe. I hope you're finding the videos useful, and I look forward to seeing you in the next playlist, where we'll probably have a look at a foundation paper, or we might do another higher paper for Edexcel. I hope that's okay, and look forward to seeing you inside the next video.